traditionally, all right? I'm gonna make them easy for you. That's my job, is to make it easy and explain it in a way that you get it. Not that you all wanna become math majors after this, but at least you won't have probably the same bad taste about algebra maybe that you have now. And we're gonna cover one section at a time per day. So today we'll only do section 4.1, Thursday we're only gonna do 4.2. So we'll take our time, that way you can get the homework done, and that last test is just gonna bring it on home, okay? I don't have my coaching hat on to make it more entertaining. All right, so if you have a calculator, please take it out, or a graphing calculator would be preferred, but if you have a cell phone with a calculator on it, that's good enough, all right, I promise. Because we're gonna do some graphing at the beginning, and then we're gonna do some computing at the end of today's lecture, okay? All right, so if you look at the first page, everybody, mini lecture 4.1, it's titled Exponential Functions, and the first question is simply to graph f of x equals 2 to the x minus 1 plus 1, okay? So I'm going to sort of do it kind of old school, everybody. You know, evaluate points. There we go. Plug in x values, it gives me y values, and we're going to play connect the dots after it, okay? So, here we go. Now, exponential functions are curves. There's no straight lines in here. We're looking at curves, all right? Sometimes the curves increase from left to right, sometimes they decrease, it just depends on the problem, okay? But as long as you follow the basic pattern I have here of plugging in x values and getting the correct y values and plotting those points, you should get an idea of what the graphs look like here, okay? So, number one, whoops, sorry. We have f of x equals 2 to the x minus 1 plus 1. Okay? Now what this tells me to do is whatever x value I plug in, I'm going to subtract 1 from it, then evaluate 2 to whatever that number is, and then add 1 to that final result, okay? All right, so let's see. Let's start with an easy one. What would you let x equal to start with?
5.
What? 5?
That's right.
0. Actually, 1 is what I would start with. You just pick the number?
Yeah.
Oh, okay. Don't do that again. Just kidding. All right. Plug in 1, everybody. What's 1 minus 1? 0. What's 2 to the 0 power? 1. And 1 plus 1 gives me 2. Look at, why am I keep doing that? I'm just excited to be here. I don't know. It's like I don't want to do this problem. All right, y'all agree with that? All right, then I'm going to pick 2. All right, plug in 2 for x. 2 minus 1 is what? 2 minus 1 is 1. 2 to the first is 2, and 2 plus 1 is 3. Keeping up so far? Oh, okay. Here comes a challenge here. 3. All right. 3 minus 1 is 2. 2 to the second is 4 plus 1 is 5. Okay? So far, so good? I need a couple more numbers here. I can't stop at those 3 here. I mean, I could, but let me go the other way. What happens if x is 0? This is going to pose a little bit of a problem, everybody. If x is 0, I have 0 minus 1, which is what number? That is a negative 1. So I have 2 to the negative 1 power. Now that is not negative 2, is it? Okay? 2 to the negative 1 power is 1 over 2 to the first power, which is what? 1/2. Y'all agree? Everybody write that down if you don't know that or don't remember that, okay? Because sometimes students, when they see a negative exponent, they think it becomes a negative number, and that's not true, all right? The value is still positive, it's just that it's a fraction now. So I have a half plus 1, which is what? What's a half plus 1? 1.5, which, is it okay to put it as 1.5?
Yeah.
Yes. Okay? Now, what happens if x is negative 1, everybody? What is negative 1 minus 1? That's 2 to the negative 2 power, correct? That would be 1 over 2 squared, agreed? Which is what, everybody? 1/4. So what's 1/4 plus 1?
1.25.
You get the idea right here, right? Y'all agree? Any questions at all about this? Any at all? I just arbitrarily picked these x values. I just used the standard roster, nothing special there. All right? So let's see if we can graph this together and see if we get the picture that's on the paper there. Okay? Well, the first point I'm going to plot is 1 comma what? 2, and then what? 2 what? 3, and then 3 what? 5. This is where I hope the curve starts. Yeah, see, we're kind of in the curve there. When it's 0, it's what? 1.5, and when it's negative 1, it's 1.25, okay? So, does everybody agree it's going to be kind of a curve there? Now, let me ask you this question. Will this graph ever go below 1 on the y-axis? In other words, if I keep putting negative numbers in here, will this ever, this over here ever go below 1? No. It'll get close. In fact, will it ever get to 1, believe it or not? No. No. It's going to approach 1, but it's never going to get there. Okay? Now, do you remember what we call that value that it's going to get close to but never reach? You know what you call that? A horizontal asymptote. Yeah, very good. Horizontal asymptote. Okay? That's when you, now, we found it with algebra, or the rational functions, by looking at the degrees of the numerator and denominator, but exponential functions also have horizontal asymptotes. And it's usually the number that's not connected to the exponential part. It's usually the part that hangs out by itself, plus or minus whatever. That's usually your horizontal asymptote, everybody. Okay, just in case they ask that question. All right? Any questions on that graph, though? See, we did it by hand, basically. Didn't even need a calculator for that. Okay? Any questions? Now, the next problem we